Okay, in this section here, I'm going to be demonstrating the render to texture feature that I sort of mentioned in our timeout session, section previous to this. So hopefully you're watching them in order. If not, basically I explained that the idea of deferring known problems and issues that we have to deal with at some point as to the requirements of the engine. So to move forward with that, along with that idea, I'm going to demonstrate how we currently at this stage extract the texturing information and consolidate them onto a single sheet, image sheet, uh, as to the current textures that we have on the outer wall here, using this as the example. Now, normally, what I do is I defer everything till the end when I'm happy and content that I have the overall ele- elements, required elements in place, based on doing a straight ahead design workflow, meaning, create the environment, texture it by just using my image manager program, dragging and dropping, moving around the UV mapping, getting things to line up to where I want with total disregard as to requirements, as to a specification. And then once I have all that done and I have all the desirable layout, let's go back to the overall map here again. Um, at the same time, I'm looking at these kind of things here that, I'm not really quite satisfied that they're at this stage uh, completed. They need more work. I need to put a little bit more into the design, uh, experiment with a little bit other textures by just dropping them on there, then maybe adding in some detail like I did the back wall here. But as it stands, I'm more or less going to commit to this back wall itself, that it is in some form of in it is actually somewhat completed to the what I want, ultimately. I'm not gonna. I'm not quite. I'm not satisfied with what I have here as a finished result. I want a little bit more. You know, real life type of damage that you would normally see. This is too static still. Uh, it's uh, it's too definable as a wall texture. So, but it's a really good, still a really good base. I'm satisfied as it being completed as that base. But as I said, I normally would defer this until I have everything in place and then do everything in one go rather than doing patchwork like this. Um, but since we are going to make what would be uh, a considered a commit to the design, we're going to kind of lose the ability to get back to this in this shape and form as referenced by different images. So what I want to do before I begin doing any destructive type of edits to it is to make a clone of this object. I'm going to call this back master back wall. So with that selected, I'm going to use the layers feature in 3ds Max to create and add this to a layer, and I am going to freeze it and I'm going to hide it. So now, and then rename this to master back wall. Now, we can always now, if I hide that as a selection, I can always now go back to my layer, bring up my master. Because it is frozen, it doesn't show any texture. If I unfreeze it, it shows the texture. But in the freeze position, I can't inadvertently select it if it does pop up, or make phantom edits, which is a term I just invented, which means that just if it's in the scene, you can inadvertently make a change to it. Now, one thing I need to check on it is something that does catch me from time to time. You can see over here it says, if you read what it says here in the modifier panel, you could see that it is in boldface type. This means that I cloned it as an instance, so any modifications I make to one is transferred over to the other. So with it hidden and out of the way, if I decided I needed to get this back again, then I'm kind of out of luck because the edits sort of bounce back and forth. So we need to make that unique. Boom, and then we can freeze that and hide it. Another option that we have available to us is we can select this and we can go save as, save selected, and we can save this out as a modular piece that we can always merge back in at a later date if we want to. We don't have to, and then it's out of the way. But since I know that I know the connectivity type of problem that we can have that will botch this up and make it more or less useless as a copy. That's been resolved, and we can go ahead, freeze that, and hide that, get that out of the way, and we can go unhide all. No, okay. So with that selected, I can go isolate selection, and we will talk a little about rendering to texture. Now, there's the usual way of generating a lighting solution in most maps is you take two components, the textured surface with the diffuse texturing and so forth onto it, along with its layering, like for example, a normal map, bump map, specular map, and I hope one day we'll actually have a gloss map, and you would then layer that into separate images. Then you would generate a lighting solution as to how lighting affects the surface areas, and that is saved to another map, usually referred to as the light map. Now, the light map is just a kind of gray, kind of to a kind of black to white gradient of how light is affecting various different surfaces. Some engines does this rather well, uh, but the one thing I don't think I've really seen is an engine that actually has the ability to ray trace or bounce lighting. This is something that CarMax talks about all the time. You always hear them that saying, "Oh, one day we're going to have a ray trace solution." Now, what he's referring to as being a ray trace type of solution is the ability of an application like 3ds Max to have a real, honest to goodness rendering engine is the ability to bounce light. Uh, uh, that's so things like you have like Metal Ray, RenderMan, these kind of rendering engines. They more or less do the same thing in different ways with different types of features. Neither is better than the other. They do things different. We could use the scanline rendering, but what it boils down to, the key feature that all of these rendering engines have is they have the ability to bounce lights off of different surfaces. So, talking about materials types in itself, um, let me bring over the material editor so we can see what kind of material we actually have applied to our surface here. As you can see, we have this big run of different IDs. These are the IDs that are generated as I start throwing textures onto various different surfaces. We have a combination of 10 materials assigned to a multi-sub-object material type. So this would be the material type in the box. This would identify this as being the material, which in this case it's a standard material. And if we go down to maps, we can see in the diffuse slot here, this is the actual texture applied to the standard material type as part of the hierarchy that is the sub-object multi-material. Confused? Okay. Now, 3ds Max has many different types of texturing materials depending on the type of rendering engine that you're using. And the different types of materials behave differently from one another based on the rendering engine that you use. So if we're looking at the rendering engine, it doesn't really have the ability to make a poor looking scene look better by its own nature. It needs elements like a material type where there is enough procedural or parametric type values that you can assign to it. There needs to be lighting with information that pertains to how that lighting disperses its effect within the given volume of space. And the rendering engine just basically manages all these different components that we put into the scene. So once again, we're back to the idea of painting with lights. In essence, we have uh, what looks like a three-dimensional object, but it's still on a two-dimensional plane. So when we're looking at from this perspective, as in depth perception, based on the perspective, we want to be able to kind of manipulate the changes in lighting and shadow effects as if we had, say, for example, this was a rendered image in Photoshop, and we can come along and we can use our paintbrush to paint in lighting and effects. And the reason I'm suggesting the painting with light idea in the first place is is it's gets you to start thinking about using light elements which are not really lights. There is no there's no volumetric to that lighting effect unless you, of course, you you create that effect. It basically looks for the surface, and then it looks at the information of the surface, and then it uses that information to calculate if we go like, for example, render boom, and it does this. So right now we're just using the system lighting system, so it looks flat and uninteresting without any shadows, effects, or so forth. So uh, in this case, our viewport is our canvas within a three-dimensional space, and we're using lights as we would if they were brushes in Photoshop to add in, you know, the dodge, burn, multi-layering, and so forth. As let's just kind of look at what we have here. Um, we have pro materials. If we look down here, we have architecture, blending, composited type materials where we can, we can composite up different types of materials that we want, different types of shader effects, and this all will allow us to kind of paint this all into our texturing layer based on the idea that we're going to be using the render to texture feature. So hopefully I didn't cause too many heads to explode. You can always go back to the beginning and go over this again if you need to. Um, but moving on here, uh, what we want with all these things into in effect, in other words, at some point I'm going to change, say for I want to change the actual material type that's applied to this to say, for example, an architectural type of material type. Architectural material type behaves differently when light is splashed against it as opposed to, say, for example, the standard material. You know, when you bounce light, if it picks up a gray off the floor, it's going to bounce and it's going to project a gray kind of tonal balance that you would normally see when when you have a reflection of light off of two different surfaces with a variation in different colors between the two surfaces. So this is the kind of something that I felt was important to kind of mention up front, uh, because uh, obviously I cannot within the limitations of this tutorial explain all the different properties of the materials that you have access to. And it's just a matter of a question if you really experimenting to see what kind of effect you can get out of it using pro-type materials. It already has, for example, um, predefined material types. So if I want to do, I'm doing a wall here. Let's see if I can quickly find something that was be pertinent to being a wall. Paint. Paint. Let's check out paint. Okay, nothing really exciting in there. Stucco. Okay, say for example stucco. you know, um, the I guess the original type of material that we're dealing with here is either a stucco or a plaster. I'm sure we can find a plaster type of material, and then we can select this for one of these prototype materials, apply that, and then whatever texture that we've generated off of this, we can put that into this predefined pro material and regenerate the end material type. Okay, 15 minutes of explanation is enough. I think you know, we can always cover a little bit more in depth if we have to on the types of materials that we can use if there's a general interest into it. But moving forward here, the goal is just to take the materials that have been applied to this by default and put them into a power 2 type of map based on an ideal. Now, the ideal here is always be working with the highest quality of materials that you need until you get to the point that you have to uh, downgrade them, let's say, to make them fit the requirement and the specifications. This is something I advise my guys to do is always make it more than what you need because you can always make it less. You can't take not enough and make it do more. It's just an impossibility to do it that way. But if you start with the best materials, 4K master textures, and always thinking of deferring until the last moment, then you're going to get the best quality out of your map design possible. So moving on, um, what I want to do is there's the amount of actual texture layers I need for this. I want to put this on a single sheet because, like I mentioned, the goal here now is to generate our lighting solution directly into the texture using the render to texture feature. So I want to get the most out of this as possible. So I'm going to break this down into two 2048 by 2048. Is that right? Well, you know what I mean. Into two separate texture images by detaching these two items. So I can get the most space, most of this texture information onto a single image. Okay, if that's selected, I'll press 0 on my keyboard, and this brings up my render to texture dialog box based on the object that I'm selected. So I'm going to change the name of this. I'm going to call this uh, outer wall 1. Naming your objects is rather important, but once again, it's something that you can defer until you need it. But if you're working in a pro environment, they'll probably want you to be naming everything all the time. 1, 2. Okay, I did spell that right. Yep. Okay. Let's make sure it's just all spelled the same here. Oh, oop, there we go. Okay, so we got outer wall 2 there now selected. This should be outer wall. Whoops, I need to change that to outer wall 1. Like I said, you get the mistakes. Okay, so that's outer wall 2, outer wall 1. I select both of them. You can see that both of these are popped up in our dialog box here. And well, we need to take need to set this up. And what we need to do, well, I'll explain this a little bit more when we get there. I need to go to my UV editor, add that to it. And what we want to do, what we're going to be doing now is we're going to be remapping our textures to a different mapping surface. In this case, we're on map channel 1, which is the same channel that my base texture is on. So when we're working with channels, multiple channels, um, you can think of it just as that, as being a channel, a direction that information is taking. In this case, we're on channel 1 with our textures, or with our UV mapping, and our textures are on channel 1. Now what we want to do is take the information that's on channel 1, move that to channel 2, and then back again based on um, resampling our texture. So I'm going to bump this up to 2. I want to move my UV mapping over, obviously over to channel 2. I can then open up the editor, and as you can see, here's all these separate images that I planed out into these sections based on the individual textures. I believe if we go, oops, if I go to IDs here, you can see all the different IDs that are assigned to each of these surfaces. So we have 7 IDs across 7 different elements. So now we want to be able to project this information in here. Since we moved to a different channel, our UV mapping on channel 1 is still intact. Our textures are still being rendered in channel 1. We can then remap channel 2. Now, this is where things get a little easy because all I have to do is flatten my image. Decrease the spacing, say to 0.1, turn off rotate and fill holes, and then yeah, I'll leave that on 40. No, let's take that off. Set that to 0. If I hit OK, you can see now that my image has been remapped to fit and packed in as best as the software can do onto UV map channel 2. So to take a look at what we got going on here, you can now see that our we've remapped it, but our texturing hasn't changed. See, if I move that around, nothing. It doesn't move. So we now need to do the same thing to the other map. We need to take our UV mapping and move it onto a different channel. So we have some way of projecting. So same process. Less chit chat, quicker work. Select by face. Okay, mapping, flatten, set to 0. Tighten up the spacing because we don't need it too much. This kind of spacing it gives it, and set those off. And now that gives us all of our texturing maps all spaced out. But as you can see, I did make a mistake. I in fact redid my UV mapping on channel 2. So no big deal. What we'll do is we'll go over here and we'll just delete that off. As I said, it's a non-destructive edit as long as it's still on the stack, and we can delete it. That brings us back to square one. So we'll go back to UV mapping, and this time we are going to move everything onto channel 2. So with everything on channel 2, we open up the editor, and then we can select, boom, and we can then remap this out onto planar surface, boom. And now when we move it, it's all good. We're set. So we have our mapping all set up the way we want it to. Okay, so now we just turn that off and we select that and we select that, and you can see that the two elements, outer wall 1 and outer wall 2, show up in our render to texture dialog box. So now what we need to do is to select these. We select that one. We do actually these are all selected, so we can do add complete map. Okay, what information do we have here? And we enable, we want to push. Actually, the easier way I found to do this is to just select them one at a time so we can get the information directly to these parts one at a time. You can do them in a stack order like this, but it gets a little bit befuddled, needless to say. This way we can sort of keep track of things. The padding's good. The padding is the distance, the overlap of the texture itself as defined by the outer edges of our UV mapping here. So padding is 2. Well, we bump that up to 3. And then what we want to do is we want to take the information that's UV mapped and textured in channel 1, take that information that's in channel 1 and push that into channel 2, and then in a sense retexturing our maps into a single image plane. Okay, so we're going to set that up, as channel 2. Our texture map, once again, the biggest possible surface area we can give it, and the most logical one here, of course, is 2048 by 2048. We want to turn off shadowing effects because we want to extract the exact texturing information out of this and move that into, uh, come on, into a completed map. Now, let me put this over here. Okay, this is outer wall 2, complete map. You know, we'll stick with the default for now. We can always change it. I'm going to make this a TGA and leave this at the setting here. And that sets up this one. This wall here, wall number 2, outer wall number 2. Okay, so we select the other one. We do the exact same thing that we just did. Less talk, more action. We're going to add, um, I think I might have forgotten to add, oh, nope, so you can see we already added it. It's as a completed map. We're going to send this over uh, to our kill room as outer wall uh, completed map. Boom. Okay, and making sure we're going to push this out into channel 2. It's pretty cool to watch it render, but if it gets too time consuming, I'm going to pause things so we can keep things down to the half hour requirement. Okay, and also I think I'm going to get a glass of water. I'm getting a little dry here. Okay, just to kind of double check, we select the two components here, and we need one more thing. Okay. This is still There's still lighting information that's being presented into the scene that will be pushed into the texture when we render it out. Now, if I was to render this out now, you would see various different surfaces of level intensity that do not match the texture itself that has been applied. So for example, the system lighting system, the default lighting system could cause this surface here to be kind of lit, but this surface area is going to attempt to do it dark and so forth, and we'll get shading effects into our surfaces, which is what we don't want. We want to consolidate a single texture image sheet as if this was going to be our default texture. Granted, it's 2048 by 2048, but we can always repeat the same process anytime we want. We can extract and remap our textures in various different ways. Also, I'll leave the cautionary till when I'm done here, so we can just keep on program. Okay, stay on target. Now, as you can see, we cannot see our light. Yeah, that's because when I created the layer, I also activated it as my default selected layer. So what I need to do is simply go up here, tell it to go to the default layer, and then I add my light to that layer and it pops back up again. See, like I said, I make mistakes on screen, you get to see the solution. So obviously if you're following along and you just did what I said you should do, then you obviously just ran into that problem. Okay, so anyways, I'm going to go to my general lighting surfaces here, and under advanced effects you can see I can select diffuse and specular, which means that this light's going to behave in that manner. If I was to render this out now, um, we've got some good lighting effects on there, but once we start putting everything in there, we're going to get shadowing effect, blah, 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 and that's no good to us. So what I'm going to do is I'm going to select ambient only. Now, in essence, what ambient is, it's a global, universal brightness and contrast control. It's going to take every surface in our scene and light it equally, which means now that we can extract our texture image verbatim as if we were just manually relaying our textures out onto a separate sheet. So I'm going to go ahead and select this and select this one over here, and we might have to do a couple of passes depending on the intensity level. But as I said, there's lots of different ways you can make changes on the fly, and what we want to be worried about is deferring any of the kind of problems as to requirements until the very, very end when it does absolutely does matter. So I'm going to go ahead. This is all set up now. And as you can see, we're running out uh, at a 1 to 2 ratio, meaning that this is half the size of what it actually this image is. But we're projecting out the texture image verbatim, and we're able to see if there's any kind of mistakes in here. This kind of plane here looks a little bit darker, but that's the texture, and a little bit different here, and so forth. Now, the advantage of doing it this way is we can also generate all our submaps, like specular map, bump maps. We can then go in and we can create random changes with Photoshop, or use the Canvas Paint program to add in even more random. I'm going to put a signature in here, for example, nudge, nudge, wink, wink. Um, um, Put it on, blend posters into the wall, that kind of thing. And this is the first image that's being rendered out using ray trace. Well, we're not really using ray trace. We're using fire and gather to create our base texture image. So, anyways, I'm going to pause things here for a minute so I can stop talking and wasting time. If I can get over to the pause button. There we go. Okay, we're finished rendering out our two texture, our two images that we need to now apply to the changes that we've made. But as we look at, let's just kind of look at the image here a bit. We have like a line here, for example, that needs to be blended in better. I don't see anything else in this sheet here that needs anything anymore, let's say, buffing up. So this is looking acceptable. Now, because it is an image, uh, we can now apply this to our material, or to our objects in the scene. And I'm just going to go quickly over to my directory off screen here. You know, sorry, I can't do that. I'm not going to be able to demonstrate this on screen because there is some top secret stuff here that I don't want you peeking at. Um, there we go. We got this directory here. A little hard to find at times because there's a lot there. You really do want to see it, don't you? Okay. Anyways, here we go. I got my two. Let's see if I can just kind of nudge this over. Here I got my two render to textured elements here, 9 and 8 megs together. Now that's not bad at all as far as load goes. Just so you know, our internal budget for texture limits for a map is 350 megabytes. So a map this size, we can use the render to texture feature to bake our lighting solutions, which is like the ultimate power that you can have, and still come in under budget. Okay, so now we have our outer wall 2. So what I'm going to do is I'm going to go over to my directory here, drag and drop our completed texture onto that there, grab this over here, do the outer wall map number 2, and change that there too as well. But it looks kind of funky, doesn't it? Based on our current lighting in our scene, it doesn't look anywhere near what we had. It looks like the remapped version. That's because our UV map, as you can see, is still on map channel number 2. But by default, we've just replaced the texture that's in channel 1. So what we need to do is move our solution back to channel 1. And this is where things begin to get a bit destructive, and why we make a backup of our efforts to ensure that we can always go back to a non-destructive edit. So let's go ahead and just right click on that, and we want to move from channel 2 to channel 1, and ta-da, our texture solution has popped up. We go over here and we go move back to channel 1, and it didn't pop in because I did not replace the texture as to this being outer wall number 1, And here's our new texture map. We'll throw that on there and the problem is solved. And now you can see that we've back to the to the solution that we have once again that we wanted, except we have a fail here on one of the sections. It obviously didn't get section properly selected. I don't know why. Let's throw an edit poly modifier on the stack and take a look at what's going on there. We go down to UV mapping, and then we'll do a open editor and see where we're at. Okay, it's way over here. So we missed a, an element that was supposed to be as part of our solution here. Somehow this got emitted as to mapping it over again over our new mapping and so forth. That's why we make a backup of our non-destructive edit so we can redo this again, and I'll fix this off screen. Um, but the process is there. You see how we're able to remap our textures onto two 2048 by 2048 a power to texture. Use that as a process and defer this as the last step of actually meeting the requirements of the engine. And to kind of back up as to a warning, uh, a 2048 by 2048 texture itself is not going to represent too much of a performance hit as is applied unless you apply a multi-stage shader effect. So you're asking it to draw multiple times a 2048 by 2048 texture, which can drag down your frame rates and create performance issues depending on the type of sub stages that you're using. So if we're adding on for the worst evil shader effect would be the environmental effect, where it has to take information from the environment and redraw that over and over. So if we did an environmental effect on this surface, for example, even though it has a minimum amount of draw calls based on the total number of surfaces, you can literally drag your frame rates down from 125 down to 30 or even less than that. So using the render to texture feature, since we're baking the added textural lighting solution into this surface area, we really don't want to have to use any type or need to use any kind of shader effect to begin with. And it's my preferred preference to avoid using them at all, because it literally says in the instructions, do not get abusive or make overuse of shader effects, as it does represent a a a CPU based calculation that has to occur versus that ultimately we hope to be able to render an environment out through hardware. So, anyways, I hope I hope this wasn't too confusing. I do tend to work fast when I get into a groove. Uh, let's do kind of an isolate and hide all. And as you can see, I have issues with overlighting. Um, just to mm, I might do that as an amendment as to how once we get to talking a little bit about adding lighting elements into here to get the kind of effective one, because obviously when we rendered the texture we changed the overall tonal balance, so we'll need to correct that uh, by maybe using the if we go to render exposure control, by using the exposure control we can balance out the overall lighting effect as it pertains to the environment, so we can make sure that our tonal balances are correct. But this isn't really a bad thing, because once again it is just an image, so we can take it into Photoshop, desaturate it, and make corrections to it, change lighting values until we can get this exactly to match up. And I'll probably do that off screen to correct this using my backup once again. always be mindful of when you're making a destructive edit that you can always go back and make corrections. If something like we had a problem we had here, for example, pops up, and we're not committed to having to redo everything from scratch.